So now that we've gotten a little bit of the basics down, just using a table of values to graph the parabola, let's look at some more characteristics. Symmetry and vertices. Parabolas have a geometric property called symmetry. The vertical line that divides the parabola in half is called the axis of symmetry. And if you'll remember from the examples on the other page, you could draw a line down the middle that kind of splits it in half. The axis of symmetry contains the vertex, which is the minimum or maximum point on the parabola, depending on which way it opens. Okay? So let's talk about the axis of symmetry. For the parabola y equals ax squared plus bx plus c, where a does not equal 0, the line x equals the negative of b over 2a is the axis of symmetry. That's the equation of the line that splits that parabola in half and contains the vertex. For an example, the axis of symmetry of y equals x squared plus 2x plus 5 is the line x equals negative 1. Now how did they get that? Well, let's try it. X equals the negative of b over 2a. In this case, b is 2, so we've got the negative of 2 over 2 times a, which is 1, 2 times a, which is 1, which equals, I forgot my equal sign, the negative of 2 over 2, which equals negative 1. So the equation of the axis of symmetry is x equals negative 1. You must write the equation with the x first, because that's the equation of a vertical line. So let's look at this example. Y equals 2x squared plus 4x plus 1. Write the equation of the axis of symmetry. Well, in y equals 2x squared plus 4x plus 1, a equals 2 and b equals 4. So we're going to write our equation. X equals the negative of b over 2a, which equals the negative of 4 over 2 times 2, because a is 2, and that equals the negative of 4 over 4, which equals negative 1. So the equation for the axis of symmetry is x equals negative 1. How convenient that it was the same. Okay? So if we know the x value is negative 1, because that is the axis of symmetry, and the vertex is on the axis of symmetry, and I need to find the vertex. Well, to find the vertex, I plug the x into the equation to find out what y equals. So y equals 2x squared plus 4x plus 1. So now let's plug in that x value to see what the y value is to give me my vertex. So y equals 2 times negative 1 squared plus 4 times negative 1 plus 1. Yes, it's important to put those negatives in the parentheses. So y equals negative 1 squared is just 1, and 1 times 2 is 2. And then 4 times negative 1 is minus 4 plus 1. So y equals 2 minus 4 is negative 2 plus 1, equals negative 1. So y equals negative 1. No, the x and the y will not always be the same. Just coincidence. So the vertex is negative 1, comma negative 1. Now, it says identify the vertex as a maximum or minimum. Remember, we have to look at a. If a is positive, then the vertex is the minimum because it opens upward, which means the vertex is the very lowest point. So in this case, it's the minimum. And now it says identify the y-intercept. Well, how do I identify the y-intercept? I can look at my function. Look at C, because the y-intercept is always 0, comma C. So 0, comma whatever C is in the equation. So the y-intercept in this case is 0, comma 1, because my C is 1. And then they graphed the function for us. They didn't even have to create a table of values on this one. We just graphed a function. I know that my vertex is negative 1, so I can put that. I know that my y-intercept is 0, comma 1, so I can plot that. Now, because it's an axis of symmetry, you see that dotted line running down the middle is the axis of symmetry. I can use that line of symmetry to help me find other points. I know if 0, 1 is a point on the line, and that's 1 away from the axis of symmetry, then negative 2, 1 has to be another point on the line because of the symmetry property. Okay, so there's 3 points. I've got 3 points. I can draw my smooth curve, and there's my parabola. So the exercises down at the bottom ask me to graph the parabola based on the information that I'm given. I don't have to create a table of values in this case. You can if you want, but you don't have to. So we're going to determine whether the function is a maximum or a minimum, state the max or min value, which would be the vertex, the domain and the range of the function, find the equation of the axis of symmetry, and then graph the function. It looks like a lot, but it's not. So we're going to start with whether it's a maximum or minimum. A in this case is positive 1, so we know that it has a minimum value. So I'm going to write minimum right here. Okay. And now we got to find that minimum value, which would be the axis of symmetry first. So we're going to do x equals the negative of b over 2a, which equals b in this case is 0. Hello. 0 over 2 times 1, which equals 0. So my axis of symmetry is x equals 0, which is the y-axis. So here, and I'm going to identify it with a dotted line. So now I plug in that 0 to find out what my y-intercept is, and my vertex, excuse me. So y equals x squared plus 3. Y equals 0 squared plus 3, so y equals 3. So I know my vertex is 0, 3. 1, 2, 3. There's my vertex. And we know it's the minimum. Okay? So in this case, I could plug in another point or so, but I just know it's the minimum value. We've got the domain, which is always going to be negative infinity is less than x is less than infinity. And my range, we know that's a minimum value, so the range is y is greater than or equal to 3. And we have everything that we need. So in this case, I could plug in some numbers. It doesn't ask me to, so I can just kind of know it's going to look something like that. And there's my parabola. May not be perfect, but it's okay for our purposes. So in this case, I want to do another one of these with you, and then I'm going to let you do this rest for practice problems. So we're going to take y equals negative x squared minus 4x minus 4. A is negative 1, which means it is a maximum value. And then we're going to use x equals the negative of b over 2a, which is the negative of negative 4 over 2 times negative 1, which is the negative of negative 4 over negative 2, which is negative 4 divided by negative 2 is positive 2, so that equals negative 2. Because negative 4 divided by negative 2 is positive 2, and the negative of that is negative 2, so my axis of symmetry is x equals negative 2. So, excuse me, I'm going to go to x equals negative 2, and I'm going to draw a dotted line for my axis of symmetry. That's the line that's going to cut the parabola in half. Now, let's plug that negative 2 into the equation to find what the y value is. So y equals negative 2 squared minus 4 times negative 2 minus 4. So we have 4 plus 8 minus 4. So y equals 4 plus 8 is 12 minus 4 is 8. So my vertex is negative 2, 8. Wow, how in the world am I going to do negative 2, 8 on this graph? That's a great question. So I'm going to use a different value. I'm going to make each one of these equal 2. 4, 6. So negative 2 comma 8 is right there. And it's okay that this value is still 2, is by 1. And so now I need to find my y-intercept, which is negative 4. I feel like I did something wrong. Negative 2 squared minus 4 times negative 2. No, looks right. So now I'm going to use my y-intercept, which is negative 4. And so 1, 2, 3, 4, that's where it's going to cross. And I can go over here. That's another point on the line, or on the parabola. So I have my smooth curve here, and a smooth curve here. And there's my parabola. The domain is negative infinity is less than x, which is less than infinity. And the range is y is less than or equal to negative 8. So I've used everything I know about parabolas to find all the information that I needed to graph the parabola. So what I'd like for you to do now is to do the 2 problems on the other side of the paper and this problem. Take a picture of both sides of your notes page and then submit that through Edmodo.